screen আসবেন আসবেন Welcome to the second live session introduction class 2 of database management systems. We have received a number of queries through different media. So, we have made a compilation like the last time, and we will go through them and try to answer some of them which are relevant. So, this session has the objective of addressing the queries from you all and the issues that you have faced. This is roughly till about the end of 7th week. The first question, again it is about the question is about relational algebra, as we have repeatedly said that you should send specific question, because here what do I answer. So, I can just advise that you read module 12 again. If there are specific questions you put forward, then we will try to give you the solution. On SQL, we have a number of questions. Again, queries and construct table, there is nothing that I can answer. More clarification needed in SQL. Again, it is certainly not possible to go through all the SQL modules again. So, you read and send a specific query. There is this query, the third query, which is Wikipedia about PLSQL, is also quite not clear. If you mean the PLSQL page in Wikipedia, then I have given the reference. Of course, you could have googled it yourself, but when you follow Wikipedia for different information, be careful, because Wikipedia is a non-moderated site, it is not reviewed by experts. So, the information that it carries is of the quick and dirty kind. So, there is no authenticity and is not usually accepted in the as a reliable source of knowledge, but so as a first reference you could, but obviously authenticate that from some good course site or content. The next question, how to find keys from the given table. Again, the question is not very clear to me. I am interpreting it in two possible ways. One is possibly, Aishwarya, you are trying to ask that if you have some instances of a table, then whether you can find keys from that. If you are asking that, then it is not the proper way, because by looking at a certain, you know the basic definition of a key is you have one or more attributes which uniquely determines all the attributes of that relation, or in other words, if I have any instance, not a particular one, if I have any instance of that table, then if two tuples match on these attributes which form the key, then they must match on all the attributes of that relation. So, given it is possible that you might be looking at a particular instance of a table where you see certain condition of being satisfied between two or more tuples, but that may not be strong enough to, you can make some guesses from that, but that may not be the really the reason or the basis for deciding what is a key and what is not a key. We have discussed about various types of keys in live session 1 also. We had done it in earlier in different modules. Please keep in mind that keys are design constraints at the schema level. So, something which is a key, you should be able to reason about that even without any specific instance of a relation. So, they cannot be derived from more instances, but they will have to be derived from the based on the functional dependencies, the real life constraints that you expect to exist on the relations that you are dealing with. Shiva Kumar wanted to know about, I want to know about key constraints of a relation. So, I am assuming that you wanted me to highlight the constraints relating to key that can be expressed in SQL. So, these are the typical ones. You can say keys have to be not null, because certainly if you have null, then you cannot check for uniqueness. Keys are certainly unique values, without that you certainly cannot have duplicates. Then we have the concept of primary key, which is the key on which a particular relation is usually indexed and stored, and the foreign key, which is in terms of interrelationship between two or more relations, where you are saying that one or more attributes in a particular relation is actually forms a key in another relation. So, in that cases we mark them as foreign key. We have check, default, these kind of constraints that can be put forward. Moving on, explain the difference between candidate key and super key. I do not know why this question is repeatedly coming, there must be some reason, but in the live session 1 we have done a detailed discussion on this. Again I would just repeat, here we have tried to give a completely different example to explain this concept. So, this is about software releases of a company, which every release has these attributes. It has year, month, date, major release number and minor release number, and we assume that if the company makes only one major release in a year, or rest of all are minor. So, if we consider in that way, then year, major, minor, if we take these three, say year, major, minor, if we take these, or if we take year, month, date, major, these are all super keys. That is, if two tuples match on them, then naturally they have to match on the rest. So, they are unique. But we will not call these as candidate keys, because these set of attributes, though they uniquely specify the tuples, but there are subsets of them which also uniquely specify the tuples. So, there is redundancy of attribute in terms of this. For example, if I just take year, month and date, that itself forms a key, or if I just take major and minor, that also uniquely determines all the attributes. So, these are what are called candidate keys. So, candidate key is one which is eligible in every possible way to be a key and is minimal in nature. Super keys are those which are keys, but may not necessarily be minimal in nature. So, every candidate key in that way is a super key, but every super key may not be a candidate key. It may have redundancies, and we particularly use the term candidate key to mean that of these possible candidates which could have behaved as a key for a relation, if there are multiple such keys, then one will be designated as a primary key, and we have explained in terms of storage requirement, indexing requirements, as to you have to finally store the data in terms of one key. You cannot rest of all that can be indexes, but the actual B plus tree has to be in terms of certain specific key. So, that is the one we specify as a primary key, which has to be non null, has to be unique, and so on, and all others which are keys, they are minimal, they are called candidate keys, and any superset of any one of them can be called a super key. So, please work out more examples to get a better hold on this. So, consequently, no subset of a candidate key can be a key, because it itself is minimal in nature. Okay. Normal forms, there are a whole lot of questions on normal forms. So, let me do something, let me quickly go back to these were discussed at length or in all over of modules 16 to 20. Let me just quickly take a dig into module 19, where we specifically talked about this in terms of the normal forms and normalization of schema. So, a question that has been coming from many of you is to why should we normalize. Again, if we do not normalize, then the main reason for normalizing is in terms of different anomalies that it comes across, the update, insert and deletion anomalies, which we have explained that if you have redundant data, then you might have anomaly. If I have redundant data which is repeated in different tuples, then while I am updating for example, then it is possible that I update one copy and I forget to update the other copy. So, the primary goal of normalization, always remember, is to eliminate redundancy, and if you can eliminate redundancy, then you get a lot of benefits. You not only your anomalies reduce, the possibilities of anomalies reduce, but it also makes it easier, more compact to store that data, to index that data. Storage becomes easier. It becomes easier to write queries, because in that process you actually when you normalize, the logically related attributes come together in terms of the tables, and the relationships become very explicit in terms of the relationship tables. So, usually it becomes easier to write queries in terms of those, and though the data dependencies become very clear, and in that, so there are several motivations. So, overall it becomes more efficient, the efficacy increases, and it becomes easier to work with the consistency of the database. So, we talked about different cases of anomalies. I will not go over them again. Please go through the video. If you, I am sure these are quite straightforward and you will have no difficulty. So, in terms of the overall normalization, the way you have to globally see it is, if you start with a schema originally, a schema is which is basically a collection of attributes which is forming a relation, then you go by every stage of normalization, you check whether it is a first normal form. So, every normal form going from the first to second to third, if you go along, you will see that we are just increasing the set of constraints. So, in the first normal form, we are saying that, do I have multi-valued attributes, that attributes which can take, or do I have multi-part attributes, so composite attributes. So, we are asking that is every attribute such that it does not have many components. For example, if date is represented in terms of the date, year and month and year, 3 components, then it is a composite attribute. We would rather either like to keep the date as a single unique value, or we will need to do something about putting them separate. The other possibility is, when someone has some attributes can take multiple values for everything else remaining same. All of us are having multiple mobile numbers. So, if you create a person database and you put mobile number as an attribute, then it is possible that you will get multiple values there, and that is not what you would like to represent in a single field. So, you will have to go to a form where you can represent all these separate mobile numbers in terms of separate records, and achieving that is achieving the first normal form, the 1NF. And then we see that 1NF also has this will reduce some of your difficulties, but then it still can have redundancies, and we have talked about partial dependency for that. So, if you identify partial dependencies, you try to remove that, you come to 2NF. And then still you have not done with all kinds of redundancies. So, you will still be able to find transitive dependencies, and you go to 3NF, and the process works exactly in that in these steps. So, you will have to, if you work through the whole process of database design, and I will urge that we have released a tutorial on hospital management system, where starting from the schema we have very carefully worked through showing you what are the relations that are violating first normal form, second normal form, third normal form, and how to go in steps to normalize that. I am sure if you go through that carefully, and instead of first looking at our solution, if you actually try to solve it yourself and then match with the results, you will be able to be more clear on this. We talked about there are different kinds of normal forms. We have only done up to first, second and third normal form. We talked about Boyce Court and the fourth normal form to a certain extent at an overview level. So, these were the first normal form examples. I will skip that and go directly to the issues of second normal form. So, in second normal form, you see that it has to be in first normal form. So, you are basically increasing the constraints. You are saying that it should not have any partial dependency. What is a partial dependency? That you cannot have a dependency, functional dependency, where y decides A or y determines A, where A is non-key attribute, it is non-prime. So, it does not feature in any of the keys, not only the primary key, but it does not feature in any of the keys, and y is a proper subset of a candidate key. If it is not a proper subset, if it is fully a candidate key itself, or if it has some intersection with some candidate key, but not a proper subset, then it does not violate the 2NF condition. 2NF condition is violated provided y is a proper subset of a candidate key and A is non-prime. So, that is the thing you will always have to remember and follow, and that is the reason I am again showing this here. This is one relation of student ID, name and course name, where the primary key is certainly student ID and the course name, because student ID and course name, student ID itself determines the name of the student, S name. So, SID determines S name. So, SID and C name together will determine S name. So, in this case there is redundancy, and that redundancy is due to the fact that SID determining S name is a partial dependency. SID is a subset of the primary key, and S name is an attribute which is not present in any of the candidate key. So, it is a non-prime attribute. So, this is the case, a clear case of where we have to we have shown here as to how to normalize and what happens post the normalization. We have shown another example also here, where you have supplier, status, city, PID, the quantity, the supplier database, where the supplier ID and the product ID form the key, and these are the dependencies. This is the dependency diagram, so to say. So, you can see that SID determines status. So, the supplier ID will determine its status, the supplier ID will determine the city. So, these are the dependencies that exist, and certainly in both of these, the left hand side is a proper subset of the primary key SID PID, and status and city do not feature in any of the candidate keys. So, these are cases of partial dependency, and because of that we need to normalize the database. It is violating the 2NF form. Moving on, we have also shown that we have also discussed how to go about the third normal form, where these are the three conditions that you have to look for. First of all, your relation has to be in second normal form, that is the first requirement. The second is that the functional dependency is if it is trivial, it is okay. So, you ignore that. Otherwise, for a functional dependency, either the left hand side has to be a super key, so that it determines everything, or it is a part of the right hand side is a part of some key, not just super key, but the right hand side is part of some key. If these two conditions are satisfied for all the functional dependencies x determining A, then it is in third normal form. You will guarantee that some more redundancies will be reduced in this. And then I think, so this is a specific case of what you say is a transitive dependency, that if A determines B and B does not determine A, and at the same time B determines C, then naturally the functional dependency A determining C is should not be there, because that will be implied by the axiom of transitivity anyway. So, if you have that, then you say that you have a transitive dependency. That, so we have given examples of this. For example, here you have SID determining status, SID determining city, city determining status. So, these are the dependencies that we have. So, since SID determines city and city determines status, that is, if you take this path, if you go along this path, then you will get by the transitivity axiom, you will get SID determines status, but that is also present here. So, this is a dependency which is the transitive dependency, and you need to get rid of that, and we have shown how to do that, and we have also discussed at length how to normalize in a relation into third normal form, guaranteeing that you will have lossless join and dependency preservation. These two properties, again I will remind that whenever we are talking about normalization, these two properties are very critical, that I must make sure that after I have normalized. So, I have split the relations into smaller ones based on the functional dependency conditions. Then when I reconstruct the information back, that is, I will have to reconstruct based on join across the normal natural join using common attributes. When I do that, I must get back the original relation. I should not get some more extra tuples. If I do that, then we say that loss has happened. And we also make sure that the dependency is preserved. That is, if I take the set of dependencies, project it on each of the normalized relation, then I should be able to check the whole set of functional dependencies. If it requires that I have some functional dependency where some attributes exist in one of the decomposed relation R1, the other attributes exist in some other decomposed relation R2, but there is no relation where all these attributes are there, then obviously you will not be able to check for that functional dependency based on the normalized form. You will have to do a join, and that is when we will say that dependency is not preserved. Mind you, while you do this, it is not necessarily that your original set of dependencies have to satisfy this property, but you have to work with a set of functional dependencies which are equivalent to the original set of dependencies. If you have a functional set of functional dependencies which are equivalent to the original, that is, if both of their closures are same, then and in the set that you are using, with that you can guarantee that you will be able to check every dependency in the decomposed relation, then you say that the functional dependencies are preserved, and that is the third normal form normalization actually guarantees to us. So, lot of examples have been worked out, we have given problems also. So, I would request that instead of actually, let me just go back to, so this is let me just go back to this. So, if I go back here, so there were all these questions. So, I tried to again explain, but certainly this has been done over multiple modules. So, this cannot be explained in 10-15 minutes, but please go through, and all these are discussed here. So, all these questions from many of you I have put together, and if you have specific doubts, if you have a case that this is what you are not understanding, some of you have raised those questions. So, that becomes possible to be answered, and this is the purpose again I have summarized here as to why do you normalize. Going to next set of questions in normal forms. If normal form depends on the combination of prime non-prime. Okay. So, this is a you are saying that what happens if the left hand side is a combination of prime non-prime attributes. The reason question is, the property is very simple. The left hand side has to be a proper subset of a candidate key, that is all, and the right hand side has to be non-prime. It must not occur in here. So, I think Nirav had sent these examples also, where I have a schema which has attributes A, B, C, D, and where A, B is the key, and then the question asked was whether A, C determines D, does it violate the 2NF. So, if A, B is the only key, then A, C naturally is not a proper subset of a candidate key, though D is non-prime, because D does not occur in this key. So, this precondition is not satisfied. So, this means that this is not a partial dependency and the relation is in 2NF. Similarly, in the other example of A, B, C, D, E, A, B is one key and C is another key. So, we have two candidate keys, and we are trying to reason about A, C determining D. Again, A, C is not a subset of any of the candidate keys, and therefore, even though D is non-prime, this is not a partial dependency and the relation is in 2NF. Use of functional dependencies. I think the main use of functional dependencies, as we have explained, is in terms of normalization and making use of the constraints, defining the constraints in the database. So, that has already been explained. This is an interesting question from Chandan. He is asking very validly as to why fourth and fifth normal form is not used in industry. I possibly did not mean that when I discussed normalization. What I meant is, it is not that they are not used, but it is that they are sparingly used. Now, the basic reason is the kind of effort that the designer would like to give and the kind of benefits that such normalization will bring in. So, fourth normal form requires analysis of multi-valued dependencies, which are certainly far more complex than functional dependencies. Fifth normal form is analysis of joint dependencies, is even more complex. So, compared to functional dependencies with which you can do 3NF, BCNF, you need a lot more of effort in the design phase, particularly when your design is large, to be able to normalize in fourth or fifth normal form. But if you look into a large number of actual designs, that is what people have done over time. It has been found that for most databases, normalizing in third normal form itself removes most of the dependencies, most of the redundancies, and it is quite okay to work with the third normal form itself. So, that is more a practical experience, that the situations which particularly need a fourth and fifth normal form decomposition which will give significant benefit in terms of removing those redundancy are relatively less occurring. So, the benefits are usually marginal. So, industry goes all by return on investment policy. So, it is normally considered that there is not enough returns to get in doing the fourth or fifth normal form. Storage and file structure, this example I did not really understand what is the difficulty. So, we have again worked this out here. It is very simple that you have to you have the total size of the storage and you are given the page size. So, if you divide you will know how many pages are there, which is straightforward, and then for to access so many pages what is the address size that you are using. You are using a 32-bit or 4-byte address. So, you multiply them, you will know the total array size of paging that you will require. Well, I mean, we have again worked it out, but I thought this was quite straightforward. The next question from Twisha. Unfortunately, Twisha, I do not understand what you are trying to know. What happens when data gets deleted from the server? All that I can understand, it gets deleted. You must be having some queries behind this, but since you have not specified that, I am unable to give you any focused answer. So, I will request that you post in more details in terms of what all doubts are existing in your mind regarding the deletion of data from the server, and is it about the system crash, or it is about removing records, deletion of records, or you are talking about removal of tables altogether, deletion of indexes. So, there are so many different ways to look at this. If you let us know what the specific query is, we will try to answer it on the forum. Indexing and hashing, how to implement practically indexing and hashing in DBMS. Yes, we have discussed briefly in module 2930, but however, I would not say that this treatment has been deep enough so that you can actually study this and go over and start implementing them in reality. That if you really have to implement, then you have to go deeper in study of specific algorithms, and there are a lot of practical implementation strategies. Because of the paucity of time, we could not go into that depth. So, if now or in future you have specific queries regarding certain implementation strategies, you can send it to us. We will send specific pointers to where you can learn about more of the implementation details. But in the present course, it is just a first level course. So, in that we have not been able to go into those details of how you actually take care of different implementation strategies. How does data encryption affect index schemes? Very simple. Every data that needs to be encrypted must be encrypted. So, if you index on the data which is not encrypted, then naturally once the index is accessed, then those non encrypted data, the raw data will get exposed. So, the strategy is simple, that if certain fields are to be encrypted, so they are encrypted and then used in the index. So, there I mean, for indexing, if you are looking at certain properties of the data, for example, we have talked of whether the data is whether it is highly repeating data, that is there are large number of records, but for that field you have only few select values, or it is widely varying data and so on. Those properties will have to be looked at not based on the raw data, but based on their encrypted forms, otherwise the system will violate the basic security aspects. ER diagram, Vandita, I am sorry, you are saying entity relationship diagram, where is the question? So, please go back, read and ask specific question. In transactions and concurrency, the question is, please summarize the serializability topic one more time. Again, I do not know, Kumar Nitish, as to how I can do that in 5 minutes. So, go through the module and ask specific question. The few things that you have to keep in mind is, first thing is it is a concurrent situation. So, what is the ground reality that we have? We have transactions which are sequences of instruction that must happen in the order in which they have been written. They are achieving a certain task. So, they are we have repeatedly taken the example of transferring certain amount of money from one account to the other. So, the steps that will have to be done are in terms of instructions, and within a transaction they must happen in the same order. Right. Now, if in the whole system there were one transaction at a time, all these issues will not arise. The question is, there are multiple transactions that are happening. So, even if you simply take the situation of a banking system where there are several accounts and money is being transferred between them, those are all different. So, you are transferring x amount of money from A to B, y amount of money from C to D, z amount of money from E to F. So, these are all different transactions, even though in terms of actual instructions they may be the same set of instructions. Now, if all these transactions have to take place at the same time, then the question is, how do I execute them? One possibility is I do transaction 1, complete everything, transfer x from A to B. Once I am done, then I do transaction 2, which transfers y amount from C to D. Then I do transaction 3 and so on. If I order the transactions execution in this manner, then we say this is a serial schedule. A schedule is how you are making the transactions work. So, a serial schedule is a basic schedule, which means that at any point of time a transaction is taking place, and this next transaction will happen only when this transaction is finished, this transaction is committed. Right. Now, if I just restrict to serial schedules, then it is quite possible what will happen is, in the system you will have very slow, very low throughput. That is, the temporal behavior of the system, that the time it will take for all transactions to finish will be quite a lot, because in terms of many of these transactions you will have not only the internal CPU based computation, but it will also have a request to disk to read data and bring it into the memory in the storage buffer or in the transactions private area and so on. These are quite time taking. There will be steps where your final result has to be written back to the database. So, you will have to do a write and an output. We have discussed all these steps. So, while these things are happening, the CPU is free, or while you are reading something from one part of the disk, something else may be read from some other part of the disk. So, what we want to do is to run multiple transactions concurrently, which means that I may be doing instruction 5 of transaction 1 and that needs some more time to finish. So, I would like to do instruction 3 of transaction 2, and it is done, I will do instruction 4 of transaction 2, but then that also is taking time. So, I can do instruction 7 of transaction 3 and so on. So, I can take the transactions, take their instructions and mix them up, and when I mix them up, I make sure one thing, that their original order in every transaction cannot be different, because that defines the logic through which a transaction is getting executed, is achieving the result. But between multiple transactions, the instructions may be mixed up. I can do few instructions of one transaction, then few of the other transaction, few of the third transaction, few of the fourth transaction, then few of the second transaction and so on. And the order in which we arrange them in this way is called a schedule. Now, when I do a schedule, then the question is, obviously it is possible that when I do the schedule, we have shown several examples that when you do a schedule without respecting what the transactions are actually doing, without respecting how the read write is happening, then it is quite possible, if you do that arbitrarily, then certain data may get lost. You may read some wrong values. You may overwrite a result which has not been read by the proper transaction which was supposed to read it and so on. All these different kind of problems can happen. And for that, we make a basic condition that while the transactions are scheduled, whatever way they are mixed up, whatever way the instructions in the transaction are mixed up, the final result produced must be like a serial schedule. They must be achievable by one of the serial schedules. So, mind you, when you are in a concurrent situation, your result often may not be the same, result often may not be unique. For example, very simple, we think of, say I have an account and I have say 100 rupees in that account, and I am supposed to pay for my say public provident fund, which for which I have to pay 1000 rupees to the public provident fund account, I have to transfer, and I am expecting to get a payment from Himadri for 2000 rupees. So, there is one transaction which will transfer 2000 rupees from Himadri's account to my account. There is another transaction which will transfer 1000 rupees from my account to the PPF account. Now, you can see that if I how I serially schedule it, I am not looking at concurrency. If I serially schedule it, the consequence may be different. For example, if the transaction that transfers 2000 rupees from Himadri's account to my account is done first, my account will become 2100 rupees. And then if the transaction that transfers 1000 rupees from my account to the PPF account is done, then 1000 rupees can be transferred, my account will become 1100 rupees, my PPF payment will happen. But think about the other way. If first the transaction that transfers 1000 rupees from my account to PPF account happens first, what will happen? It will fail, because I have 100 rupees only, and you cannot transfer 1000 rupees from an account which has only 100 rupees. So, that will fail, that will not be possible, it will give you an error, and then the transaction that transfers 2000 rupees from Himadri's account to my account will happen. Now, in terms of basic database parlance of transactions and validity, both of these consequences are considered valid. Nobody is guaranteeing that because Himadri is going to pay me 2000 rupees, my payment to PPF must go through correctly. It may go through correctly, it may not go through correctly, but the basic point is there are two possible serial schedules. Now, when I mix up the instructions of different transactions into a schedule which is not therefore serial, then the final effect of that must be like one of the serial schedules. So, if I mix up the instructions of these two transactions, Himadri transfer from Himadri's account to my account of 2000 rupees and transfer from my account to PPF account for 1000 rupees, if I mix up those instructions into a schedule, then the effect of that schedule should either be that I have been able to make the transfer to PPF and my account balance is 1100, or the transfer to PPF account has failed and my account balance is 2100. No other possibility, no other result will be acceptable. So, every schedule which is not serial one must be equivalent to a serial schedule. And we have studied about two different ways of making out that how can I, if I am given a schedule, how can I check whether it is a serial schedule. So, which means that whether there exists some serial schedule to which it is equivalent, and for defining that equivalent we have introduced the concept of conflict in terms of read and write. So, the basic idea is I can read from by two transactions I can read the same data in any order, it does not matter, but if one of the transactions is writing, then their order of whether I read and then write, or I write and then read, or I write and then write cannot be changed, because that will violate the basic consistency of the data that I am reading and writing. So, with that we have defined the concept of conflict, we have defined the conflict of in a given schedule, how can you interchange instructions, side by side instructions of two different transactions. Obviously, you cannot interchange instructions of the same transaction, they will have to happen in the order they are given. But if I interchange the order of two instructions which are from different transactions, then I am allowed to do that, provided it does not conflict, that is I do not change the read and write of the same, or write and write of the same data by two different transactions. If I can keep on doing such changes in a given schedule without creating this conflict, without encountering this conflict, and effectively transform that into a serial schedule, then we will say it is a conflict serializable schedule, and so that is an acceptable one. And similarly, we have defined a weaker form of serializability, or the view serializability, which necessarily say that every transaction must read whatever way I schedule, in the given schedule the transactions must read the initial value in the same way. Any value that they read at any stage must have been written by the same write instruction of the same transaction in the other schedule, and with that we have shown that it is you can get some more schedules which are view serializable, even though they may not be conflict serializable. We have discussed that conflict serializable schedules are always view serializable, but not the other way around. So, this is a basic idea, and based on that we have tried to give two solutions of serializability. One solution is in terms of using locks, that if there is a possibility of conflict, then how do you ensure that the conflict will not happen, that you have a lock, so that before you make that change, before you do a read or you do a write, there is shared lock and exclusive lock, you have to acquire that lock, and only then you can do the operation and you release the lock. And based on the order in which the different transactions acquire the locks, the serializability will be enforced. Now, this was also required because certainly beforehand there are so many transactions that can happen in a database system. So, beforehand I do not know what those transactions are, so that I cannot offline do an algorithm and say that okay, is it conflict serializable, is it view serializable, tomorrow a new transaction will be fired. So, I will have to analyze it against any other possible transaction. This is an explosive problem. So, a real solution is if I can make use of locks and do that. So, that is the next thing that we have discussed. We have discussed different protocols. Using locks also is not has its own evil. We have seen that it may lead to deadlocks, which are key areas where there are two data items that the two transactions need at the same time to work with, and one transaction is holding a lock on one of those data items, the other transaction is holding a lock on the other data item. Naturally, none of the transaction can proceed because it cannot get the lock on the other item which the other transaction is holding, and it needs both the items to proceed. Simple case of deadlock, there could be several other that we have discussed. And so, that is something, if deadlock happens, then we have discussed about strategies of how you break the transaction, you will have to basically roll back and then restart the transaction, all of that. It can also happen that if once you do this, then it creates another problem that you may get into live lock. That is, there are when the transactions are rolled back and they are scheduled again, then when it comes the next turn to allocate the lock, it is possible that a particular transaction is repeatedly becoming a candidate for allocation, but it is not actually getting the lock. So, all these different kinds of problems arise when you want to achieve serializability through the implementation of locks. And based on that, we have also discussed about a timestamp based algorithm protocol. It is a very simple protocol which shows you that if you follow that kind of a protocol, then you will be able to get deadlock free schedules all the time, even though live locks are still possible. So, this is just I mean, based on your request, Kumar Nitish, this is the summarization. I do not know how far that really helps you, but because we have actually already discussed all of these through this, but this is just another quick recap of the whole thing. Coming to applications, application of database benefits from this certification course. You have probably not yet checked into module 40, possibly this was written before the module 40 was released, and in module 40 we have talked specifically of what different kind of things you can do. We have talked about common RDBMS systems, we have talked about non-relational RDBMSs, which are really not a part of this course, is not in the syllabus, but we have just given you some glimpse in terms of what are called the non-relational or NoSQL databases, and what is doing the rounds in terms of that. And most importantly, we have talked about a skill job profile matrix. So, I can just pick it up and give you a glimpse of that. You go through this. This module is not particularly for your assignment or examination study, but this is for your understanding with the course. So, you have tried to work out a total skill profile mapping in terms of what are the different job profiles that are typically available if you have good database knowledge. Of course, you need the basic CS knowledge with that, and based on the different years of experience, and on the top these are the different skills in the database. How deep is your skill? Can you just understand specs and schema? What kind of jobs you can get? If you can do coding, if you can, on top of that, if you can do normalization, some more jobs that you can get. If you can work with the architecture, performance optimization, administration. So, these are all spectrum has been discussed. So, go through this presentation and go through the video of this, you will get answers to most of question 1, that Tanisha Lakshmi's question, how we can connect it to real life. Of course, there are variety of applications. We have also talked of in module 40. We have talked of a number of companies, at least I have listed there about 30 companies who work on at various levels of database applications and development. How to use database with applications, this I will certainly, I do not know what to answer. We have discussed this in module 21, 23. We have talked about embedding in module 11. In live session 1 also we have had discussions on this line. So, I will have to skip that. If there are specific questions, you can again shoot to us. Jignesh has an interesting questions of which I do not have an answer. How database management systems is used by companies to tap the rural market of India? I would think that it is like any other market, they will frame business policies to benefit rural customers in this case, and then frame the IT solutions on top of this, but I have no clue as to how these things are done. I suppose this question should be asked in some kind of a course that deals with business development management and those kind. I am sorry, I cannot, I do not have much insight into this. These again are about things which we have discussed certainly, and they are big. So, I cannot go through them. Just to point you back, procedures and functions, these are the slides and modules where these have been discussed. If you have specific questions, feel free to ask them to us. Hospital management system is the tutorial that we have released. So, it is a very detailed 30-page document which discusses about specification, shows you how to extract information from those specification and basically identify entities and identify relationships. Then we have shown how to design the schema, shown how to refine the schema based on different functional dependencies that you can identify, and also based on the typical queries that you would like to answer, and we have shown all processes of normalization and denormalization through that to come to a final relational schema, and then we have shown how to code for a number of different, how to create the tables really, the DDL part and the queries, and this we have done based on MySQL actual implementation. The screenshots and all that have been painstakingly worked out by the teaching assistants. So, those are all frozen there. So, if you just even somewhat blindly follow that after installing MySQL in your system, you should get a good grasp of the whole process, and if you have questions beyond that, please feel free to ask that. I do not think on career aspect database sufficient to choose it as a life career. No, certainly one subject cannot lead you through life. It can be a major area on which you can develop your career, but at the same time to progress further you must have very sound knowledge of algorithms, data structure, programming. To go further in database systems, you should know operating system well. A fair idea of networking will help, because things are heavily distributed these days. And if you want to really go cracking into the leading profiles of today's market, then you have to equip yourself with knowledges in data mining, data warehousing, basic big data aspects, machine learning and all that, so that you can get to variety of this. So, well, it's a good starting point, but you will really have to supplement with all this knowledge to be able to make a effective career, and the skill profile matrix that is there in module 40 will give you some outlines of that. How many companies ask that you know DBMS? I wish I knew. Unfortunately, I do not know, but I would presume, having seen hundreds of my students go through this, I would presume quite a large number of them do. and we have compiled a list of a large number of companies in module 40, which certainly have positions where they ask about your knowledge on database systems, and it's very much in demand. Future in DBMS research, Pulkit, this is again something which cannot be explained in depth. There is so much to be done in terms of distributed databases, efficiencies, compacting databases in smaller and smaller size and so on. But I think the most exciting amount of part of research is happening in terms of non-relational databases now, which is I have given a glimpse of that in module 40 in terms of NoSQL databases that particularly of 4 kinds, and the common ones MongoDB, Cassandra and all that, where all people are doing what kind of some of the things. So, we can get started in some of those, but really the area is very, very open. And Salman, is this beneficial for me? Salman Ahmed, unfortunately I know you very little to be able to say yes or no, but if your objective is to learn database and use it in your career profiling, that should help you in that. There have been several other questions. Question about hospital management we have already answered. Whether concepts learned in this lecture enough for NPTEL examination? Yes, it should be. Do the assignments well, revise those, look at the correct answers. How we can get through high command for designing any type of you are meaning good expertise in that. So, it's the way you do for every subject. You study the text properly, solve assignments, try more examples and all that, go through those steps. What mean architecture? We have explained it at the initial slides. So, it is basically the set of specification rules and so on. Can I get certificate of this course? Actually, you should not be asking these questions here. Yes, those are general NPTEL NOC procedures. I want more practical knowledge. The tutorial should help you in this, because it is really long. We have already released one tutorial. Placement questions I have answered. Thanks for providing classes. Thank you, Sai Kiran, for appreciating our efforts. Why not we create a live project together? It would have been Utkarsh, it would have been great to be able to do that, but please understand such a course had when it started, it had 30,000 plus enrollments. So, it's very difficult to do anything live project in a collaborated manner. Even as we understand, 3,000 of you are going to take the examination. Even at that scale, MOOCs model does not allow this. So, tutorials are the second best that we are trying to help you with, so that you get at least some flavor of how things are done. How to evaluate assignment marks? This has been explained. Fees of the course I cannot comment. I am a civil student, of course, I do not know civil engineering. How do I get 600 in NEET? I do not know. Who to develop my skills in game designing? Again, these are all beyond the scope of the database system. So, these were the compiled queries. I think I will take up another query which came in just before I was coming for the live session. So, that was regarding insertion in B plus tree. So, the question was in terms of we had done about 2, 3, 4 trees which has 3 kinds of nodes, 2 node, 3 node and 4 node. And we know that when we try to insert in a 4 node, it has to split and create a combination of 2, 3 nodes, and with that we had shown an example. So, there is some doubt in terms of that example. So, I have added one more slide here to explain that. That is the question is I will go through the steps again and show you where the confusion really arose, but I am just trying to highlight that when you actually implement a 2, 3, 4 tree, then the question of when you split a 4 node can be done in multiple ways. So, typically there are 2 strategies of node splitting. One is called the early strategy. So, in the early strategy, what you do is if you are searching for some key element in the tree and you come across a 4 node, as soon as you come across a 4 node, you split that. It is not only in the case of insert, or not only in the case of that this is the 4 node where a key has to get inserted. So, whenever you come across a 4 node, you split that. So, this is called an early strategy. Another is a late strategy. So, where you split a 4 node only when you are about to insert a key in that node. Now, these naturally give you different keys, different trees, but both of them are valid, both of them will satisfy the same complexity of order of height, but the results will be different, and so you check at different texts or different sites, you will find different strategies being followed. I have shown here with early strategy, because if you do an early strategy, then you make sure, because any time you are doing a search or insert anything, you come across a 4 node, you have split it. So, you make sure that there are very few 4 nodes in the whole tree, in the whole 2, 3, 4 tree. If you do a late one, then it is possible that you come across an insertion case where you are inserting a key into a 4 node which is at the leaf, and for that you have to split and take the middle key and insert it to its parent, which is also happens to be a 4 node, and then you split and take the middle and take to the parent of parent, which also happens to be the 4 node. So, all over your path from the leaf to the root, all the nodes could be 4 node. So, it will still mean order height number of operations, but the actual time of doing this one single insert will be very, very high, because you will have to do so many splits at the same time. You can distribute that cost much better if you follow an early strategy. So, that is the basic reason. I will just show the differences. If this is where you had started, these are the inserts, there is nothing special here. So, now you have to do 20. So, you search for the 20 and split it. Here in this case, since it is a leaf node, the early and late strategy will actually give you the same result. So, you split that, you insert 20, again you insert 50, after that you insert 40, you insert 40, you get here, then you have to insert 70, which is again a leaf node. So, early and late gives you the same thing. Whenever you search is the time when you have to actually insert. So, you split, get this, and then you have inserted 70, you insert 80, again you have a leaf node, you insert 15, this is at a leaf, you want to do this for 90. So, again 90 has to go in here. So, again late and early are same. So, you have to split and then you have to insert it 90. Okay. Up to this point, the split and let give you the same results. Now, suppose in this tree you are trying to look for insert 100. So, to insert 100 you will have to first search for 100. So, you come at this root node and find that this is a 4 node. If you are using an early strategy that I have followed here, then this 100 is not supposed to go in here, this 100 will finally go in here in this node at the 80, 90 node. But this 30, 50, 70, the first time I come across this, because I am trying to look for the key 100, since I have come across a node which is a 4 node, by the early strategy I will split it. So, I have split it here. So, that 4 node is gone. Of course, this has not been searched after being constructed. So, this has not been split, but this has been searched and therefore, it has been split, and then you insert 100 into this. So, 100 comes in here. So, this is what will happen if you take an early strategy. Now, what will happen if you take a late strategy? If you took a late strategy, then you are here. So, by the late strategy, you will not split when you are traversing this, because you are not going to insert here. You go down, you find that this is a 3 node where you can do the insert of 100. So, you will simply do the insert of 100. So, in the late strategy you will get to this configuration, and you can see the kind of the difficulties that I was talking of. You have on this path and as well as on 80, 90, 100 to 30, 50, 70 root path, as well as 10, 15, 20 to 30, 50, 70 path. On both of them you have multiple 4 nodes, and this could happen over multiple depths, and that could cause a particular insert to be very, very slow. So, that is the difference of the early and late strategies of splitting. I am sorry, this was not explicitly mentioned when we made the presentation. So, I will get this presentation uploaded, and this is in terms of 2, 3, 4 tree. So, you can understand extending it in the B tree also, B plus tree also, you will have similar strategies, and therefore, when you try to compare between 2 or more text, you are not expected to get the identical result in every case. some will follow this strategy, some will follow other strategy, some will follow the, in case of B tree, some will follow that the leaf node must have must be at least 50% full, some will relax and say that it must have at least one record. So, there are strategies little bit vary here and there, but overall if you look at the core idea is that the height of this 2, 3, 4 tree, B plus tree, all of that, the height will always remain constant. So, every leaf node is at the same depth, and that is manipulated in a way so that depending on the number of keys that can go into every node, that is the page size, it is the in terms of the number of nodes log to the base of the number of keys that can go in the page size by 2, and so which ensures that your height is always logarithmic in terms of the number of nodes you have, and therefore, you can have a very efficient search. So, this question was coming up, so I just tried to answer that. If there are more specific questions on this area, please let us know, we will try to answer those. So, Himadri, if you have anything, so there are some more that are coming, that have come in live. Please explain advantages of NoSQL DBMS over SQL1. Again, Deepak, this is a nice question, but I am sure if you have looked into module 40, this is specifically we have given a comparative statement there. We have actually compared and shown as to what are the we have shown this here that what is a non-relational database that does not, and this is primarily used for handling big data, for unstructured data. So, we have talked about some of these comparisons between what are the advantages and disadvantages, and also let me just sensitize you that when we talk about say NoSQL databases, that the term is little bit I should say a little bit confusing, because a NoSQL database necessarily does not mean that there is no use of SQL at all, because underlying tables are often again relational, but what you are meaning is not only SQL. So, you have other ways of querying that, and you have other ways of, so it is primarily for these different parameters. So, you go through those carefully, and if you have further questions, then we will try to answer over the forum. How we can specify locking and unlocking of data in SQL. So, these are this has been discussed I think in the TCL we have done, right. So, you look up the TCL part, the transaction part of the SQL, the transaction command language part. So, you should be able to find the answer, otherwise you can post that, we will write to you. In assignment 6, question 3 B plus T, are you sure the question is correct, Arihant? I do not have it here offhand. So, I will just have a look, and we will respond to you on the forum. So, if you can also write specifically as to what you think is not correct. So, that will help us, maybe there is something that we have overlooked. So, we will check. Can 1NF have multi-valent dependency? There is, probably you meant multi-valued dependency. There is nothing like multi-valent dependency that I know of, Arul. Can 1NF have multi-valent dependency? I mean, yeah, I mean, a relation can be in 1NF, it can have functional dependencies. It will see normal form is the way you organize the schema, and dependencies are natural reality of the real world, the functional dependencies, multi-valued dependencies. So, they exist. Now, if you are asking that if there is multi-valued dependency, whether a relation can be in 1NF, yes, it can be. If the relation is in 4NF, then necessarily it satisfies the multi-valued dependencies, and it is in 1NF. So, the question will have to be asked differently, that if a relation is in 1NF only and not in 4NF, then is it violating some multi-valued dependencies? Then yes, but you may want to make the question more specific. Then Sunita is asking R, A, B, C, D, E, H. So, you have given a situation of 3NF and BCNF decomposition with 6 attributes. We will just work it out and post it on the, because certainly there is not enough time to work this out here. So, we will just work out and post it on the forum. So, we will get that, everybody will get that. So, why BCNF is considered stronger than 3NF? It is simple, because you have stronger restriction. You are saying that in BCNF, what you are saying? In BCNF, you are saying that it has to be in 2NF, in 3NF also you are saying that it has to be in 2NF, that part is common. So, it has to be in 1NF as well. Now, what you are saying in BCNF, you are saying that every dependency means every functional dependency must on the left hand side have a key which determins something else. So, if it is a key, will determine everything else. So, all dependencies have to be of that form, only then you will consider that it is in BCNF. In 3NF, you have an additional condition. In 3NF, you have both of these. You allow it has to be 2NF, which is common. You allow trivial dependencies, which you allow in BCNF also. So, that part is common. You allow that if x determines A, then x has to be a super key, which is the BCNF condition, that is fine. But you are also allowing the presence of the case of the transitive dependencies. So, that is so you have done a little bit of relaxation in terms of the functional dependencies that you will allow in the third normal form. So, it is less rigid. So, we have already shown examples in terms of our discussion, where we have shown that there are relational schemes where you can do a 3NF decomposition with lossless join and dependency preservation, but you cannot do a BCNF decomposition which preserves the functional dependencies. So, BCNF is more strict, but the problem is certainly that reduces more of dependencies, but the consequent problem is for any relational scheme you can do a 3NF with lossless join preservation, with lossless join and dependency preservation. With BCNF that is not the case. With BCNF you can only guarantee lossless join, but you may not be able to guarantee dependency preservation, which means that in terms of the actual runtime checks it becomes more difficult to work with BCNF normalization, unless it naturally is preserving the dependency. So, that is the basic reason. Is there any other question? Okay, then. So, I think that is about all that we had from you. So, we have tried to again work through the key study and practice areas in terms of SQL, query coding, relational design, normalization. Again, I have tried to go through some of that. I have tried to talk about the concurrency of transactions and serializability, and we have released the tutorial on design and coding. So, I would expect that in the next couple of days there will be a lot more questions, specific ones coming in from that if you have difficulties on that. And well, wish you all the very best for the completion of this course and for the final examination, and kindly continue to post queries, but I request you again and again and again that please post queries which are specific, give examples that this is what I cannot do, this is a case which I think is wrong, this is a alternate solution to maybe some solution that we have given. In those ways, do not if you put just queries that what is this and what is discussed, then obviously the forum cannot effectively address that. So, thank you all very much and wish you all the best.